All right, good morning. It is snowing, it's cold. I mean, I guess it's pretty appropriate for Advent, but let's get to it. Day 12. Honestly, at this point, we've already had some hard problems, so if you're still sticking with this, congrats already, because you're doing awesome. If you've been following along with me, you already know how many days I've struggled on, so anyway, I'm excited. We're like halfway through. It's feeling pretty good. Okay, day 12. Your ferry made a decent progress towards the island. Oh, it's cold. But the storm came in faster than anyone expected. The ferry needs to take evasive actions. I don't even remember getting on a ferry. I skip so much. Evasive actions, apparently that's important. When the captain used PA system to ask if anyone can help you, quickly volunteer. The navigation instructions, which is your puzzle input, consists of a sequence of single character actions paired with integer input values. After staring at them for a few minutes, you work out what they probably mean. N means north, S means south, east, west, left, right, forward. Interesting. Left, right, and forward mean that we need to keep track of not only your position, but the direction you're facing as well. The ship starts by facing east. Only the left and right actions change the direction the ship is facing. That is, if the ship is facing east and the next instruction is N10, the ship would move north 10 units, but would still move east if the following action were forward. Okay. At the end of these instructions, the ship's Manhattan distance, the sum of the absolute values of its east-west position and its north-south position from its starting position is... Okay, yeah, so basically it's on a little grid and we're moving the little ship around and we need to keep track of where it's moved to versus where it started at, and then that's the answer, is how far it actually moved. I'm assuming Manhattan distance is literally just a more in-depth. Oh, actually, no, hold on. Manhattan distance. Manhattan, I think, is laid out in square blocks. Versus taxicab geometry versus Euclidean distance in taxicabs. Oh. So, never mind, Manhattan is the zigzag distance? Is that right? 10 units east, north 0, east 10, north 3, east 17, north 3, east 17, north 3. Okay. 11 units, east 17, south 8 at the end of the instructions. Sum of the absolute values of its east-west position and its north-south position. Okay, so what we need to do is we need to keep track of everywhere it went, or some as we go, and flatten those, the east-west, north-south. Okay, so, well, this is like a little tiny input that they're giving us as a sample. Okay. So ship direction, I guess, and the ship direction has enum, and that is the action, I guess, that we're taking, which is a string, and then distant, and then that action is an action, and the distance. I don't know if anybody else does this, but like the first 15 minutes or so of coding every day, maybe it's first hour, it takes so long for me to like get my head thinking and write syntax again. So the options are forward, which is F, case left, which is L, right? Yeah, case right equals R, case north equals N, case south equals S, case east equals east, and case west equals west. Okay, and then I'm gonna put the extra initializer from a string in an extension in case I need the member-wise initializer later. I don't need it now, but I might. And then let's say string dot remove first. Okay. Okay, let's do this actually. Self.action equals action raw value string.substring to the string up to but not including. Okay, so substring to 1. Self.distance equals action, or not action, int from the string substring from 1, I think, right? Substring. So dumb. I hate this so much. Prefix with a max length of 1. I hope everybody that works on Swift is watching these videos because it just illustrates how insane working with strings is. Okay, string, and then I don't want suffix because I don't know how many characters it is. This is really dumb. So matches equals string dot regex. See, this is like so stupid that I'm even like thinking about using my own thing to pull out the first character and then every character after that. There's probably a better way. If there's a better way, I would love to hear it, but I don't know what it is, and I think that that's actually a little crazy that it's not just like super obvious how to do that. So anyway, it is, the first capture group is A through Z, 1 character, and then the second capture group is just a digit. Let's see if that actually grabs everything that we want here. Digit plus. Yeah. Okay, let's full match, capture group 1, capture group 2. That's what we want. Yeah, just dumb. Just dumb. So equals matches dot first, and this is matches dot last dot first. I mean, it kind of doesn't matter. Last dot last. It's only got 1 thing in it. Int and end. Yes, those can fail, but we don't care. Okay. Cool. So now we have a type that that sort of encapsulates the movement of the ship. And then what we're going to do is we're going to where does the ship start? Starts facing east, only east 10 north. So we started at 0 0. Okay. So then what we're going to do here is we're going to say let input let line directions equals input dot ns dot not compare components separated by new lines, and then map those to ship direction $0. Okay, so those are my directions. And then we know our facing equals ship direction dot action dot east. It always starts facing east. And then east west equals 0 var north south equals 0. And then what we're going to do is we're going to say for direction, we're just going to go through every one, and we're going to perform the operation. Oh my gosh, perform the operation that it's supposed to do, and then we're going to print east west north south. Are we supposed to multiply them together? I don't remember what the add them together. Okay. I'm gonna go ahead and print all of it just for this test run. Okay. Let's do it. So we're doing a switch on the direction here. So we're going to do switch direction dot action, and then I'm going to let autocomplete take the wheel. Thank you. Okay. So if it is forward's the one we're going to chill on for a second because it depends on the direction we're facing. Ooh, yuck. Okay. Well, okay, this is a bad abstraction. I shouldn't use this here, but I'm going to anyway. So forward, we're going to chill on. Left, we're going to chill on. Right, we're going to chill on. Because all of those depend on facing. North is pretty simple. North, south plus equals direction dot distance. North, south. Ooh, is north. Let's see, hold on. North 3. At the end of these instructions, the ship's Manhattan distance, the sum of the absolute values of its east-west position and its north-south. So it doesn't matter, the sum is the absolute value. Okay. Minus equals direction dot distance, and then east-west plus equals direction dot distance, and east-west minus equals. So it doesn't matter. I don't think it matters as long as we're consistent here in what it means to go north, south, east, west. Okay. And then last thing. What's the last thing we need to do? We got those distances, east, west. Okay, I think that's good enough. Okay, we're going to then, for forward, we're going to switch on facing, and the default is assert false. We should not ever put something that's not a valid north, south, east, west in here. Okay, so facing, if we are facing north, so it's literally do this based on which way we're facing. Evaluates to a constant. What? What are you talking about? Switch condition evaluates to a constant. I don't know what that actually means. Weird. Okay, and then what we're going to do left, we're going to do another switch. So if we're facing north, then facing equals dot west. If we're facing south, then it's now east. If we're facing east, east, turn left. We're now facing north. And if we are facing west, we're now facing south. Okay, and then I'm actually curious, facing right 90. Is it always 90? That's going to be weird. If it throws us other things. Is rotation always 90 degrees? That's not the degrees. I'm calling that out there because that if it's not always 90, that could throw us a loop. Like if it's like negative 90 or something, like that could be a problem. In fact, I'm gonna look at the puzzle input. There's no negatives. There are, there are 180s. Are there 360s? There's 90s. There's 90s and 180s. Cool. All right, it's not. So we'll have to fix that in our sample. This is right, but it's not going to be right. Because 180 actually flips it. In fact, I can actually do this if direction dot distance equals 90, then it's west. Otherwise, it's south. I'm gonna do that on every single one of these. What an answer full of copy and paste. So much room for error here. But it's like all of the time it would take me to actually reason through a better way of handling these probably is not worth it. Oh, interesting. I'm already committed. I'm going down this path. So if the direction is, this is kind of cool. So if you want to take more time on your solution and be more thoughtful about it, if the direction is an interval of 90, then you're going to do one of these actions. But if it's a 180 or a 360, some interval of 180 or 360, then you always just flip the direction, which is kind of cool. So, if you're looking for a robust solution, that would work pretty good. Okay. Okay, so that's it. Let's go back to this sample input really quick. Let's run it and see what it actually spits out for us. Fatal error. Did I do it wrong? Matches. Oh. Yeah. See, I don't even remember my own abstraction. Okay. 17, -8, 9. Except for these need to be absolute value. For those of you that don't know absolute value, that just means dropping the negative sign. So 25, 25. Okay, so let's try it on our puzzle input and see how bad it gets. 625, huh? Well, hopefully that works. It's not right. Your answer's too low. Okay, that's fine. So my first instinct is that the 90s or the 180s are wrong. Let's see. Just change the direction the ship is facing. That is, if the ship is facing east and the next instruction is north 10, ship would move north 10 units, but would still move east if the following action were F. Yeah. 10 units east because the ship starts by facing east. East 10, north 0. Yeah, in fact, so my guess is, so the only thing that was not handled in the test case here, so I mean, I can look at southeast and west and make sure they're right, but also left was not covered and 180 was not covered. So let's just look at our code really quick and make sure. North goes up, south goes down, east. I like to think of it the other way around, where west is to the right, so positive. But east, west, north, south, north, south. Okay, that still feels right. Okay. Let's see. Let's just do, let's find all the instances of left. 90, 90, 90, 180, 90, 90, 90, 90, 90, 90, 90, 90, 90, 90, 180, 90, 270. Okay. So now we actually have to do it. That's annoying. So it's actually, I'm going to bet that that's the one that threw us off. I did not see that 270. It's direction mod 180, I think. So if it's 270 mod 180, that's 90. But if you do it mod 90, it's 0. So it's actually, if it's distance mod 90 equals 0, then it's this. Copy, command option F. This is what we're replacing it with. Boop, 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 boop. I bet it's just that 270 that threw the whole thing off. 665. Still not right. Okay, still too low. 270. Well, that should handle. Yeah, there's more 270s. I don't know why I didn't think for 270. Of course, there's a bunch of 270s. What about 360s? There's no 360s. 540s, 1080s, 720s. Skateboarding coming in handy there. Okay. So what is the Manhattan distance between the location? Okay, so really quick, I just want to make sure that I didn't work the sample. Sample still comes out at 25. Okay, good. Didn't mess up the new line. Good. Okay. So so I think that that's right. I guess we can turn right by 90 degrees and face south. East, turning right is south. Otherwise, it's west. it remains at east 17 to north 3. Okay. F11 would move the ship 11 units to south. 11 units south to east 17, south 8. Okay. I mean, I'm kind of at the point where you just kind of start stepping through and seeing like, okay, do one of these look wrong as we're going through it. But like, I'm gonna pull up my input side by side so I can kind of follow along as it runs. So what we're going to do is we're going to, at the end of every iteration on the for loop, we're going to say print east, west, north, south, east, west. And then this is just a place for my breakpoint to hit. Okay, so it starts out at 0, 5 because it went west 5. We start out facing east, right? I did get that part right. Okay, I did. Oh, okay, hold on. East, west. East is negative. I flipped these and I did not flip these. Dangerous. This is the dangers of copy paste code right there. You hit stuff like that. 779. Dang it, still too low. Okay, back to the debugging. Okay, so west 5, that makes sense. And then forward 66, because we're facing that way, okay. South 4, okay. East 1. Forward another 78, okay. And then left 90 degrees, so facing should be south now. Do I have it wrong? Left 90 degrees. When you're facing east, goes facing east is north, right? Facing north. Am I thinking about that right? Where's they have a right there. Yeah, south. Okay. Okay, so still no concerns there. Where did we leave off? On the first, left 90, so now we're facing north. Okay, we're now at 75 because we're now facing north. We moved up 79. Okay, still looks good. 71 and negative 140. So we move south. Okay, and then forward 64, so back up again. Right 180, doesn't matter, it's just facing south now. Crap. This is not right. This needs to be if modding by 180 does not equal 0. Man, oh man. The reason being, if you haven't already caught it, is because 180 mod 90 is 0. And so you actually have to do the mod by 180 because it's the bigger value. That's dumb. This is like massaging the solution until it's correct. Wait. What did it say? Your answer's too low. 779 is too low? And my new answer is 461. That's not good. Okay, let's run until we hit our first left or right. Those are the ones that I'm still pretty convinced that we're getting wrong. So the directions, no, not all the directions. The direction is left 90, and we're currently facing east, which means we should be facing north. Facing is now north. Okay, good. Keep going. Okay, we hit right. 180, right? Right 180. And we are currently facing north, so it should be south now. We're now facing south. Okay. We're facing south, which means left 180 should be east. We're now facing east. Okay. This is a right 180. Okay, which means that we're facing east currently, so that means we should be facing west by the end of this. We're now facing west. Okay. Okay, we were facing west, and this is left 180, so now we should be facing east. Okay. We are facing east, and this is a left 90, so we should be facing north now. Yeah, I mean, these are all looking good. North is up, south is down, east is, oh my gosh. Okay, I just need to like consistently east-west. Is that really the mistake I made again? No. East is negative, west is positive. East is negative, west is positive. Okay, so that's not it. Because these two are nearly the same. North is positive, south is negative. North is positive, south is negative. East is negative, west is positive. East is negative, west is positive. Okay. So, and I don't think that like I parsed something wrong. So it's in the logic, and 461 is not going to be right, of course. Yeah. Okay. So I guess what I could do here, just to like test some stuff, because this big input is clearly not doing me any favors. Let's do. Let's just flip all these. So south. Left. Man, that's really all it does, huh? Let's forward a couple times. Rotate once. But it still should end up at 25. Okay. 11 units south, east. I kind of hate, okay, that it's not, I'm gonna have to like read the Manhattan distance now. Euclidean distance is the red, yellow. Euclidean distance. In taxicab geometry, the red, yellow, and blue paths all have the same red, yellow, and blue paths, which is a length of 12. No, we're thinking about it right. Because we're now 17 east and 8 south. And if you measured the distance, it would be some weird number. We're doing that right. At the end of these instructions, well, let's try to simplify our code a little bit. Let's do a little refactor, and maybe we can come across what's wrong. So the first thing that I'm seeing is that we can simplify is if direction, if case let, if let rotation, if it's a rotation equals, in fact, actually, yeah, if rotation equals case let, oh my gosh, why is the syntax so dumb? If case let, if case let x of course, if case let, why would you give such a dumb example of if case let? Yes, thank you. Okay, there we go. If case let rotation equals case let it's case let we're looking for ship direction dot action dot east equals direction. Is that how you do it? Direction dot action has no effect. Subpatterns didn't bind any variables. Oh, do I, since I'm not binding any variables, do I just do like this? Equals dot left or direction dot action equals dot right? Okay, there we go. Then what we can do is we say this: if it, just to make my life easier, if direction equals 0 else. And then what we're going to do is basically steal this right here, this right here, right? So if we're facing, actually, if it equals 180, that's actually all I want, because I want the normal switch cases otherwise. Okay, so that will, if it's one of these two, so if it's left or right, and the direction distance is equal to 180, then we're going to do this. So north becomes south, south becomes north, and east becomes west, and west becomes east. That cleans up a whole bunch of code. So now north becomes west, south becomes east, and then we get, so this, that's already a little bit better, a little bit less error prone. The next thing that I want to do is maybe refactor this logic down here. West becomes north, east becomes south, south becomes west, north becomes east. Okay, so I'm doing this in two places. This is based on the facing direction. Is there a way that I can just well, first of all, I want to run this and see if I end up with the exact same thing. End up at 25 still. And then does that change anything about mine? Because the answer I needed to be was like above 760 or something like that. Huh. Was that the bug right there? Nope, that was not. That's not the right answer. If you're stuck, there's also some general tips. Or 5 times on this puzzle, wait 5 minutes before we try again. US 1399. Okay, 1399 is higher. It's not telling me anymore if I'm doing it right or wrong, which is a bummer. Okay. So that's interesting that we're already, oh, shoot. And then we need to continue. Let's try that again. 461. I think that actually gets me back to what I guessed before, which was 461. Okay. So the next thing is, can I refactor this to be better? I think so. Let's see. So this is switch based on north, south, east, west, north, south, east, west. Okay. So then what we can do is we can say like func move direction, shift direction. And then it returns a north, south, east, west, maybe. Do something like that. And so then what you can do is you could say, oops, switch direction dot action, and then the case, the default is to assert false. Okay, and then what this is going to do, if it's north, we're going to return north is positive because it's up, north, south, east, west, return zero, and then return 0 and negative distance, and then see, now I'm already like I've looked at this so many times, I'm already rethinking, do I want I actually think I want east to be positive and west to be negative, because west is to the left. And then what we can do here is we can say case north, south, east, and west. For all of these, then it is let dx D north south, D east west equals move direction, and then north south, east west. Okay, and then basically I can do this same thing up here. Okay. Boop, like that. Equals. Okay, and then equals. Okay. See if I still get 461 first of all. Ooh, what? Facing. Oh, here's where I'm going to use the memberwise. Let move equals new move equals ship direction, which is going to be facing. It's facing and direction dot distance, and then that should be new move. I'll make sure that looks right at least once. So new move is east 66 because our direction was 66 and we're currently facing east. Okay. We again, oh, I was like, oh my gosh, do we really have another smaller input when we need a bigger one? 461. So we still got 461, which is a good, bad, I don't know. Left is L, right is R, north, south, east, west. I'm just all sanity checks at this point. Okay, still, I think we're doing fine here. Okay, so what else can we simplify about this? So we hit these just fine. If it's going forward, then you move north, south, east, or west based on the direction you're facing. If you're facing left, then you need a new direction. I really am like sort of at a loss. I'm kind of at a loss for what the bug is here. I'm going to take his recommendation. Just because we're running kind of long now, let's take a look at the subreddit because I'm only at day 1, and let's see what I'm doing wrong here. Let's see. Yeah, okay, fine. Rotate. Oh, interesting. That's kind of cool. They're basically using this, the positives and negatives, to reorient it. So 180 is just flip on the axis. It's interesting that they only did 90, 180, and 270. Oh my gosh, am I not handling 270 properly? I'm totally not. That's what it is, huh? I'm not handling 270 right. Because 270 is like the inverse. Crap. Well, there's my bug right there. I'm still not handling 270 right. Okay. I'm just gonna throw it up here. If it's right, and the distance, I'm just gonna say equals 270 because we know that that's still a thing. So north doesn't become south. North then becomes east. Sorry, not 270 is. Oh my gosh, no, I can't actually do it up here. Of course, that's going to be the thing that gets me. Where's my... okay. Wow. Direction dot distance equals 270. Does it? If so, then what we want is north did become west, but instead it becomes east, so it's just the inverse. I'm actually, to make this simple, I'm going to do it this way, dot east, and then I can put one of these on every line, and then the inverse of this. Wouldn't that just be dandy? See, and that's why I don't like this is like I'm not complaining about the problem, like it's my fault that I knew that I looked at the data and knew that 270 was an option. I think as a puzzle designer, it's like nice to have, you know, more problem space, and like makes it a little harder. Unfortunately, I think that like when people are consuming your puzzle, it's like, I got 34 seconds to wait. When people are trying to solve your puzzle, it's kind of unsatisfying to like to like have ambiguity, right? Like I get that it's like technically not ambiguous because it never it told us exactly that you rotate by that many degrees, but it's, I don't know, it's just it's a little annoying because you don't have any way to verify that, like, yes, I understand what each variation that it can throw at me is. So 7 times, gotta wait 10 minutes. If you're stuck, make sure you're using the full input data. There's also some general tips on the about page. Yes, 479, I gotta wait 10 minutes. Full puzzle input, I'm pretty certain I do. 560, F62, F62. Okay, I'm gonna pause the video then, since we gotta wait 10 minutes of time. The video's gonna get really long. Okay, we'll check you in a minute. Okay, fast forwarded to here and check it out. We got the right solution, 1603. How did we get it, you might ask? Well, when I was going through and handling 270, of course I did something wrong. So it was just these 4 values that were wrong for when you turn right, 270. Kind of annoying, but here we are. Let's go to part 2. Before you can give the destination to the captain, you realize that the actual action meanings were printed on the back of the instructions the whole time. Almost all the actions indicate how to move a waypoint, which is relative to the ship's position. In means to move the waypoint north. Move the waypoint north by the given value. S means to move the waypoint south by the given value. I mean to rotate the waypoint around the ship counterclockwise given the number of degrees. Oh gosh. Given the number of degrees. Action F means to move forward to the waypoint a number of times equal to the given value. Oh gosh, this is like a totally different problem. The waypoint starts 10 units east and 1 unit north relative to the ship. The waypoint is relative to the ship. That is, if the ship moves, the waypoint moves with it. Oh gosh. For example, using the same instructions as above, Okay, so I already don't want to solve this problem because it is completely different, and we've already spent an hour on the first part. Moves the ship to the waypoint 11 times, a total of 44 units east and 110. See, this is moving it to 4 units east and 10 units south of the ship. The ship remains at east 170, north 38. So I honestly don't even know how you do the rotation. I don't. Online. Wait, Grapher. Yeah, Grapher is a thing here. Okay, default, sure. Okay, so if I have a point, oh gosh, what did I do? X equal or Y equals 10. I have to like zoom out. Okay, let's do Y equals 3. Okay, so if I've got a point here, rotating at 90 degrees, I actually don't know. I just how to rotate point 90 degrees around origin. Like when rotating a point 90 degrees counterclockwise about the origin, our point becomes X, our point A, XY becomes, switch X and Y and make Y negative. Okay, so like if the point was here, rotating 90, let's go 10, 0, rotating at 90 degrees puts it there. Okay, rotating left 90 puts it there. Okay. And if you rotate it to the right, then it becomes flip X and Y, and it keeps the sign. Is that true? If you rotate it to the right, but this one's not. 16 step-by-step examples. Okay. About the origin, our point A, X, Y becomes -2, 1. That's counterclockwise. Okay. Clockwise. So clockwise then is X, Y, you flip it and the X becomes negative. $180, you flip it and they both become negative. Okay. We're gonna use this, I guess. Okay. So, first things first is, well, I'm a little annoyed that I don't know how much of this we'll be able to keep. And in fact, to keep it simple, I think I'm just going to actually move this to like a part 2 function. I'm going to move it to a part 2 because there's just junk up there, and I don't want to accidentally screw myself up by overwriting something. So the part we want to keep is this. But what we're doing is we're editing a waypoint. I guess like we already looked at this guy's solution, right, when we were looking for help. This is what he's doing. Did he use this for both parts, part 1 and part 2? Yeah, he switched his part 1 and part 2 to use the same waypoint system, I'm sure, after he read part 2. So I guess the question is, if you're going to do this waypoint system, let's read the instructions really quick. The north means to move the waypoint north. So north, south, east, west moves the waypoint. So we can keep that part, I guess. In fact, I'm going to give myself, to simplify this, var x is an int, var y is an int. Okay, I'm going to give myself a coordinate, and we're going to say ship equals coordinate 0, 0, and waypoint equals coordinate x 0, 0. Okay, so this gives us the ship and the waypoint. So they're sitting on top of each other. Moves the waypoint, rotate the waypoint around the ship, so our rotation logic completely changes. And then action. F means to move forward to the waypoint of number of times equal to the given value. So F means you're applying the waypoint multiple times. Okay, so let's keep none of it, actually. I don't trust it very much. Okay, but we have learned about 270 causing us all sorts of problems. So we're going to do switch direction dot action. And then, so we know forward, left, and right are the problem ones. We can, what did we do? We could actually, I want to change, I'm not going to change this right now because then I'll have to refactor part 1. But what I want this to do is return a coordinate, and then x, y. Just because I'm using this new coordinate thing, I want to use it all the way through. So let's do it. Now, with this one, I was starting pretty depressed. I didn't want to do this part. But I feel a little bit better knowing how the rotation rules. I was not looking forward to like trying to figure out how that worked, because that's just like a math thing that I could have spent hours churning on trying to figure out the pattern to, and I don't know, just didn't feel valuable to churn on. But now that I know that like it's an easy thing, it feels a lot better. So the next thing that we want to do is we want to do north. So waypoint plus equals move direction and we're going to do how do you do function plus equals other coordinate? Is that right? Self.x plus equals other.x and self.y plus equals other.y. Can I do that? Is that how it works? Must be static. Okay, let's do that then. Okay, I think what we have to do is, wait, what's it saying? Unary operator must have prefixed or postfix modifier. I'm going to Google this later. I actually don't know how to do this, but that's going to be a valuable thing. So what I'm going to do instead, Swift custom. I just want it. Custom operators. Yeah, let's do a custom operator. Static func left. This one has to be in out. Okay. That's what I was. Left hand side and right hand side is a coordinate, and this one is in out. And so then what you do is you do left hand side, right hand side, right hand side. Is that how you do it? Cool. Okay. I'm glad I just Googled that. Did I end up just putting it all in one? Yeah. So actually what... So we can do north, south, east, west. Okay. And then we know, so that moves the waypoint, okay, based on the direction, which is fine, right? Like this just gives us basically this is creating a new waypoint out of the thing. We'll see how much it matters. It might matter a lot that our XY, I think our XY is currently wrong. We've got north, south is X and east, Y is Y. East, west is Y. I don't know if that'll matter. We'll see. So that moves our waypoint, going back to the rules. And then left, right rotates it. Okay. So rotating counterclockwise is you flip X, Y, and invert the Y. Okay, so let's go back to our extension here, our coordinate, and we're going to say func rotate I probably have to mutating func, rotate counterclockwise times. So this will be an int, I guess. So then what we're going to do is we're going to say, because we know times can only be up to 3. So let's actually do, let's do just to degrees, and we're going to do case 90, case 180, case 270, and then default assert false. Okay, so to rotate counterclockwise, counterclockwise 90 degrees, you flip X and Y. X equals self.x, self.x equals negative self.y, self.y equals x. Okay, so that's rotating degrees. Okay, so counterclockwise XY, flip them. And then 180 is both get flipped. Self.x equals negative self.x, self.y equals negative self.y, and then 270, so 90, 180, 270 is the same thing as just going clockwise, which is you flip it and then the y becomes negative. Equals self.y, self.y equals negative x, self.x equals y. Right? Yep. Clockwise 90 is x and y flip places, but the y is the one that becomes negative. Okay, so that's counterclockwise by degrees. Let's just do normal. Rotate by degrees is clockwise. So clockwise is this one. And I'm guessing that is just the sum total of it, right? So 180 flip both. Clockwise is that, counterclockwise. Yeah, it's the same as if you came all the way around. Okay, hopefully that is right. Waypoint dot rotate right would be clockwise by direction dot distance, and rotate left would be waypoint dot rotate direction dot distance, and then move forward is you add it a multiple of times. So again, we're going to do static func multiply, left hand side is coordinate, right hand side is an int, and it returns a new coordinate. And this is return a new coordinate where left hand side dot x times right hand side and left hand side dot y times right hand side. So this just basically gives us a way to multiply a coordinate by a number, and it just gives us the multiplied coordinate. So what that ends up letting us do is saying, okay, ship equals ship plus equals waypoint times direction dot distance, I think is what it's saying. And then we don't have a facing anymore because we always have a waypoint. And then and then the end result is we print the absolute value of waypoint.x plus the absolute value of waypoint.y. Okay, let's go back to the little sample input here. We're going to find out real quick how bad this is. Okay, and then run it 3. This is from a starting position is 286, so completely wrong, not even close. That's great. I'm just gonna comment this out for a second. Okay. So F10 moves the ship to the waypoint 10 times. And then after this, sorry, waypoint equals coordinate 0, 0. Moves the ship to the waypoint 10 times, boop, 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 leaving the ship at east 100, north 10. The waypoint stays 10 units east and 1 unit north of the ship, so it stays. It stays. Okay, well then let's just step through it then and see what part I'm not understanding. So currently the ship is at 0, 0, the waypoint's at 0, 0. The first instruction, does the waypoint start at something else? Starts 10 and 1. There you go. That's, I'm sure that's a big part of it. 14, so we're already still wrong. Cool. Starts at 10 and 1. I want to be able to read these while we're going. Okay. So moves forward. So it ends up east 100, north 10. The waypoint stays. So it should be east 110. Starts east. So this is gonna bite me. Hopefully this is the only place that it bites me. North, south, east, west. Well, coordinate systems, wrong direction, 14 party. Okay, so I need to. I actually, this is an opportunity for a clean slate. So X is east, west, north, south. 10 units east, 1 unit north. Ship is 0, 0. Okay. And then we got to move the direction. So let's change this really quick too while we're doing this. So moving it north is up, south is down, and then east is positive and west is negative. Okay. Still, let's step through this. So after the first thing, the ship should be at east 100, north 10. East 100, north 10. The waypoint moves 3 units north. Okay. Which means the waypoint 3 units north moves the waypoint 3 units north to 10 units east still and 4 units north. Okay, that's good. Then moves forward 7 times, landing on 170, 38. Oh, snow truck. So east 170, north 38. Okay. And then rotate. Okay, I'm sure that already plays a big part. Still gets us at 14. Dang it. Left is counterclockwise, right is clockwise, right? Left, counterclockwise, clockwise. Okay, well, let's just do this again until we hit that point. We don't ever go left in the sample. We only go right. Is that real? We do. We only go right. Okay. Okay, so the rotate 90 rotates the waypoint around the ship clockwise 90 degrees, moving it to 4 units east and 10 units south. 4. So that's already wrong. 4 units east and 10 units south. Yeah, that's wrong. Will let me rewind to that point. Move. Okay. Self is okay, let's just rerun it. Step into -10, 4. So -10 is -10's wrong, right? So at this point, ten units east and 4 units north. This is so fun. East is to the right. Let's try that again. Whoops. Okay, so it should be 10 to the east and 4 to the north, which it is. 10 to the east and 4 to the north. And then rotating it 90 degrees moves it to 4 east and 10 south. 4 east and 10 south. Okay. 4 east, 10 south. Okay, there we go. 11 times, which is 14, which is not right. Okay, let's print ship after each one, I guess. Actually, let's print ship and waypoint after each step and just see which one goes wrong. This translation between number XY and north-south is killing me. Okay, coordinate starts at, wait, why is this? Okay, after the first operation, 100 east, 10 north, 110. Okay, and then in 3 moves the waypoint. So the waypoint is 10 and 4. Waypoint becomes 10 and 4, okay. And then forward 7 moves the ship at 170, 38. 170, 38. Rotation leaves it 4 and 10. And 10 south, okay, negative 10. The ship remains at 170, 38, perfect. And then moves the ship to the waypoint 11 times, a total number of 44 units east, landing at 214.72. Landing at 214.72. Oh, because I'm doing waypoint. I'm so, man. Little errors all day. Which gets me to 286. Oh, do I even dare try the full puzzle input at this point? I feel like what I should do, if this doesn't work, is convert my first part to use this new waypoint system and make sure I get the right answer still. And then go from there. Okay, that worked. Holy cow. What a rough day because of a whole bunch of like little problems. That's one of the things I'm going to do actually. So this is, I feel like this is the kind of problem that can come up again. So I'm actually going to, I don't need to convert this because if you remember just from looking at this guy, his part 1 is, this guy, I should give some credit. Apparent order, his or her, their solution is basically to set the waypoint to 1 to just set a heading. So I don't think that like converting solution 1 is like that technically interesting. Maybe I'll go ahead and do it just for history's sake, but I feel like this is the type of thing that like would actually be valuable for future solutions. So we're going to go ahead, I'm going to do that later and convert this to a thing that we can reuse. And hopefully eventually what we're going to end up doing is making a video where we go through each of the Advent of Code days and we say, okay, what's the reusable part of this, and turn this into a common library, because I've noticed from people that rank really highly on the daily scoreboards is they have sort of a robust library that can churn over similar kinds of problems. And it prevents you from doing the same kind of dumb bugs I did, like the 270 bugs. So dumb, because they've already vetted it, right? So I'm going to do that, learn from it. Thanks for sticking with me on this one. This was another rough one because of those bugs. I'm glad that part 2 ended up being a lot faster and not nearly as painful as I thought it was going to be. All right, we'll catch you on the next one. See ya.